Hi, my name is Umair Hashim, and I'm a principal solutions engineer in the automotive and IoT line of business at Arm. And I'm currently focused on driving the software-defined smart camera solutions from a technical perspective. This brings me nicely onto the topic of the demo, which is about how cloud-native vision workloads can be deployed on Arm using open source software for a software-defined smart camera solution. This is achieved by using container-based orchestration for edge devices, which basically means that we package our vision workloads as containerized applications or microservices, then deploy and manage them using open source container orchestration tools like Kubernetes. All of this runs on the target edge device, which in this case would be a smart camera. This is an approach that can and is being used to deploy smart camera solutions, and it is an approach that we believe is the way forward. For those of you who know and understand cloud-native DevOps, it should be pretty clear as to why we take this approach. However, for the benefit of those of you who don't, let's quickly talk about why this makes sense. Some of the requirements of a software-defined smart camera solution are maximum availability with minimal or zero downtime. This is also known as continuous delivery. The ability to upload training data sets to improve neural networks and machine learning models. Hardware accelerated execution of software-defined workloads, and tight integration between the cloud and the target device, where the cloud service providers provide apps and over-the-air updates along with overall device management. By deploying apps and services as containers, not only are you making your apps portable, but also enabling your workloads to make use of hardware acceleration if the APIs used for that workload are supported on an accelerator that is available on the target device. You can also have multiple versions of the same workload deployed simultaneously. This allows easy upgrade or downgrade between versions and ties into continuous integration workflows. Let's have a quick look at the software architecture. Here you can see that the various components needed to deploy a software reference solution, and Arm is investing in programs such as System Ready and PSA to create a common baseline for partners to land their own implementations of the stack while keeping development costs low. Using open source software components allows partners to focus resources only on the areas where they can create differentiation and add value, instead of investing in bringing up a custom solutions from the ground up and then having to deal with the support and maintenance overhead of the full stack. In today's demo, we will focus our attention only on the bring up of the execution environment on the target edge device and showcase how easy it is to bring up the highlighted subset of the software stack in the diagram shown here. The goals of the demo are to showcase the ease of OS bring up on a system-ready compliant hardware, which in this case is the Raspberry Pi 4B, using system-ready compliant firmware, which in this case is EDK2 UEFI. We also want to showcase the ease of container orchestration bring up, demonstrate multiple containers running as a single node cluster on an edge IoT device, and also show that we can communicate between these containers. For example, use one container to capture the input video and then stream that across to another container, which does the processing of the video. Let's dive straight into the demo. Here we can see that the system-ready certified Raspberry Pi 4B is running the experimental EDK2 UEFI firmware, which is system-ready compliant as well. We are able to boot and install a standard Ubuntu server ISO image, which boots off of a USB drive. Once the OS install is complete, we use the standard installation method for K3s to bring up a single node Kubernetes cluster running on the device. To get started, we use a container image that is already available in Docker Hub. The specific image we use in this demo was chosen because we wanted to use GStreamer for this demo, and it came pre-installed with this Docker image. Once the installation of K3s and the container runtimes are complete, I will transition from the HDMI video output capture over to the screen capture of the SSH terminal on my host machine to make it easier to copy and paste commands. Here, you will be able to see the two YAML files that we use to describe the two containers that I mentioned in my presentation slides earlier. One serves as a video capture pod, and the other serves as a video processing pod. The kube control create command creates and deploys the containers in the pods, and once they are ready, they automatically start running in the background. We then use the kubectl exec command to attach a shell to the running containers and ping the containers from each other to make sure that they're able to communicate over the local network. To demonstrate a more meaningful communication between the containers, we log into the video capture pod and create a dummy video stream that could have been captured from a camera and send it over UDP to the target container by providing its IP address as to the UDP sink in GStreamer. And then in the other SSH window, we log into the video processing pod and run the GStreamer command that captures the stream sent by the video capture pod. With this, we achieve all the goals that we set out for this demo. So we've been able to demonstrate that hardware and firmware compliance with System Ready can really lower the hurdles for software development, not just for smart cameras, but also for any ARM-based solution deployment, whether it's at the edge, in the cloud, or anywhere in between. Cloud-native workload deployment might sound unfeasible for the edge, but that is not the case, especially when you use lightweight container orchestration frameworks like K3s. There might be an overhead involved to moving from non-cloud native workloads to containerized execution, but the long-term benefits of portability, scalability, continuous integration, and continuous delivery-based deployment can be worth the investment. Thank you for your time, and thank you for listening in on the demo.